in it so that there's no confusion. Because it's a formal write-up, the first thing I should see in your lab report is a title page. Title page needs to have a title for the lab, so you make up the title. I don't really care what it is, but make sure it's clearly what the lab is about. I like a picture on the front cover, something to indicate what the lab might be about, and your name, date, period. All that should be on the front cover. Okay. Turn to the next page. I want to talk, before I go into it, about formatting. Upper right-hand corner in the header, your last name. So make sure it's there, please. And then lower right should be the page number. I like it to be expressed as the page I'm on out of the total number of pages. That's how I like it. So these should be in the header and footer. And if you can't figure this part out, it's okay, but they shouldn't appear on the title page. You should learn how to turn it off so that it begins on the next page. If you can't, that's fine, but then you fail word processing. So try and figure that part out. Many of you think you want to go to college in a couple years. You should figure out how to use a word processor. This is just one step. So I bet if you hit the word help on your word processor and type those things in, it'll tell you how to do all of it. So please format it correctly. If you have no intention of doing that and are going to handwrite it, then I do have some stipulations about handwriting that need to be followed. The most importantly being that you can only handwrite your lab if I can read your handwriting. Some of you, your handwriting is very, very bad. And although I will allow it on a test, I really can't allow it on the lab. You know who you are. You don't need to ask me if your handwriting is good enough. If you have to ask that question, you need to type your lab. Fair enough? But at the same time, if you wish to handwrite it, please only write on one side of the paper. Do not write on both sides of the paper. Also, I'm going to encourage you to leave adequate space around each section. So I have room to write and I have room to read it. Now, one message about submitting electronically. If you're going to submit your lab electronically, your document must be a PDF. Every word processor will allow you to save yours as a PDF. Everyone should be a PDF. You may submit it to me through my email. Email is fine. My preference is that you do the professor at Physics by Shelton. The district email will work okay, but I can read this wherever I happen to be. I can't always log into the district server to be able to get my email. So that's my preference. If you're going to send it somewhere else, or if you can't email it, Edsby is the alternative. But do not send it to my other email, please. So if you can't send it to the professor at Physics by Shelton, put it on Edsby. I would like these turned in next Friday. That's giving you more than sufficient time. Usually I give 3 days, but I am not going to read them. I'm not going to be in town this weekend, so there's no point in getting them earlier. So you have until next Friday. If you're turning them in as a hand-in submission, a paper copy, it is due in class. Since it's a Friday, I don't stick around on Fridays, so you can't come in here at 3:10 to turn it in. The door will be locked. If you are turning it in electronically, you have until 10 p.m. on Friday to get it into my email box or on Etsy. Any questions about that? Okay. I forgot something on the title page. Let me go back. But I want the name of your partners here. Bless you.
Thank you.
The people you worked with, so get their names. And I need to say this because it was an issue on the last lab. This should be your own work. Every sentence should be yours. Bless you. I don't care if you guys work with others, but I had in the last lab exact copies turned in under different names. I get that you're working with somebody. I will take the total amount of credit for this lab and divide it by the number of people submitting in that document. Does everybody understand? I'm going to make this very clear. I will not allow you to resubmit under those circumstances. Okay? You know better, and if you don't, you now do. Okay? Are there any questions? I don't remember who it was, or else I would be speaking directly to them, but I wrote it in their lap. So, all right, let's move on. That's just formatting details. Let's talk a little bit about the actual lab itself. Each section of the lab needs to be highlighted. The first section is the purpose of the lab. Both sections of the lab have the same purpose, and it's not really an experiment, it's a demonstration. So I want the purpose to be clearly articulated. It was to demonstrate conservation of momentum. That was the purpose. So I want a section labeled purpose, and I want the purpose expressly written out. So it should include the pros of the purpose, word for word. Also, it should indicate important vocabulary. Yes?
What's pros?
The word choice and diction that you use. Prose refers to the actual sentence structure and words that you put in there. You guys have not used that word before? Okay. So instead of the word prose, it should include the text that you're actually going to use. For me, I have exact text I want in the purpose. Demonstrate the conservation of momentum. Now, I want important vocabulary defined. So I'm expecting a paragraph defining what conservation of momentum is. And I expect this in the purpose of the lab. You can pull it right from your notes, but I am expecting a paragraph. That should be 2 to 4 sentences defining what conservation and momentum are, and the phrase conservation of momentum. The purpose should not take you long to write. I'm expecting that a purpose like this would be something more, about 5 minutes of work. So don't spend a lot of time here. Any question about this? No. This year I have dispensed with you guys writing out procedures. I don't really want to see procedures, which is I don't need a step-by-step description of how you messed with the equipment. It's boring, I don't read them, and you guys spend way too much time on it. However, I do want a section for this lab that is marked apparatus. And this should be a diagram. I want a diagram of the equipment that clearly labels what you measured. So any value that is measured, you need to have indicated it in your diagram. So there's going to be 2 diagrams, one for each part of the lab, with a clear indication of what you measured. If that requires that you put a sentence or 2 in there, that's fine. So if you have to say, through trial and error, we placed the cars at a location where when they separated, they struck the ends at the same time. That's a sentence that explains why you started the cars there. I don't need play-by-play. We put the cars in the track, we hit the plunger, we moved the cars to a new place and hit the I don't need any of that. Just indicate why you started the cars where you did. That's fair enough. On the second part of the lab, or the first part, depending on which side of the room you're on, you should indicate why you dropped the ball with no collision first and why you dropped the ball and had a collision after. But you should label anything you measured. The apparatus should take more time than the purpose. You should take care to try and label things appropriately. If you must, you have a week, come in and take a picture of the apparatus and include it in your lab. Some of you have video. Pull a frame from the video, include it in your lab. But I want this to express what you measured. I'm thinking this part takes maybe 10 minutes per lab, if you're careful. Any question about that? All right. These 2 are the least important part of the lab write-up, the part I will spend the least time grading. So they're worth the least amount of credit. It's the next couple of parts that actually have value to me. So the next section is the data section. I'm going to speak to each lab separately. Bless you. But there are some overwhelming things over the top of the lab that should be followed. First, data should be raw. No calculations. Bless you. This should be exactly what you measured. Off the meter stick, written on the side of the masses, as given to you by me. So things like the mass of the cars, I gave that to you. You have to trust me. The bars themselves don't have anything stamped on them. I had to give you the value. You had to trust me. And you can say, Mr. Shelton gave us those values. Anything you measured, though, should be written down exactly as you took it off of your measuring device. So if you later convert it to meters, that shouldn't be here in the data section. Now, let's talk about the track and cars. If you did only the traditional lab, then you have a comparison between car 1 and car 2. I expect to see an organized data chart. And then the numbers. It's all that has to be here. But it should be organized in a chart, and the units should be clear. Placing the units in a single place is fine. I don't need every single number to have the units next to it. Now, this is if you did just the traditional lab that we talked about in class. If, however, you attempted to do a little bit more by trying to use video physics, there's more to do then. And for that, we need to talk a little bit more about if you want to extend the lab and try and earn a little bit extra. So I'm going to do that at the end of our discussion. Right now, I am only talking about the basic lab outline. So any question about what I expect to see in the tracks and cars section? All right. All right, data for the two-dimensional. I know what your paper looked like. However, for this section, I want it drawn a little different. I want the diagram to look something like this. Okay. What I'm looking for is a diagram that looks like this. I want you to take the center line that you would have had drawn through the center and draw it as if it was coming up to the ball before the collision. So this was the center line that you would have drawn. It actually represents the velocity of the collision ball before the collision. No collision took place, so it continued to the floor. So it left the table at the velocity that it would have had it undergone a collision. So this represents an undeflected strike and therefore is the initial momentum of the system. These other two represent the momentum after the collision. The collision took place here. You should clearly identify the length of this vector and the length of each of these vectors. You could do it right on the diagram. You could do it in a chart if you wish. Since I'm asking for this electronically, you could draw this picture and then snap a photo of it and include it in your lab. Or, just like me, right here in front of you, you could draw it out. There are plenty of ways for you to do this. I'm sure you've thought of one or two. If you haven't, get a drawing app for your phone and draw it. You guys are good with your phones. You can do stuff. This angle and this angle should also be clearly indicated and delineated. So if you want to make a chart out of it, fine. Organize it in the form of a chart. Doesn't matter to me. All right, that is the data section of the lab. Just so you know, I begin reading labs backwards. I start at the end, but typically I jump around. I read the end of the lab, the conclusion, and then I go to data, and then I go to evaluation. It's the order in which I read the material. If all that's good, I glance at the other parts of the lab, usually reading your definitions. So what I'll be looking for are these pieces, these components. Since there's 2 labs being done here, the data section is going to be worth more than normal because it encompasses 2 labs. So it should be worth about a third, well, a little less than a third of your total lab score will come from what you have in your data section. Any question about that? Let's talk evaluation. There is nothing to graph in this lab. We're not comparing 2 variables like that. So there's no graphs to do. In this lab, before you even start your evaluation, you have to answer a question. And I don't know if you know the answer. And I'm not going to give it away. But we didn't time anything. Momentum is all about velocity. Yet all you took were distance measures. So before you start your evaluation, you have to answer this question. I'm not going to give the answer away. This requires conversation with your teammates, perhaps. A little bit of discussion. If you come to me next week and you say, I just still don't understand and you want to know what I'm trying to get at here, you can, and I will help you. I won't explain it fully. I'll give you some pieces that you might need. But I want you to come up with a reason why in this lab we never timed anything. We were able to do the entire lab measuring distance only. And this is true for both parts of the lab. So the answer to this question is the same for both parts of the lab. But I'm going to be a little critical about reading this answer. This is the kind of question that shows up on the AP exam. A conjecture about something of this sort, something esoteric like this. Esoteric means that perhaps interesting, but definitely off the beaten track. Something that seems unusual. They're going to ask questions like this. Now, the actual evaluation is stupid easy for the one-dimensional one. If you're not doing the video physics part for the one-dimensional portion, you're going to be calculating and comparing the momentum. Now, we didn't actually measure momentum. We measured mass and distance. Momentum is mv. We're just going to compare m times d for car 1 and compare it with m times d for car 2. It should be pretty clear that as the mass of one car increased, the distance it traveled was reduced. So this comparison should be a one-to-one correspondence. To see how closely they compare, you should calculate the percent difference. You should calculate the percent difference. Now, if you don't know how to do that, I would like it done in this way. This would be a calculation of percent difference. Find out how far apart they are and divide by the average of the two. You'll do this row by row. So you'll take two pieces of data. This will be M1 and D1. This will be M2 and D2. You'll find the difference between the two. Those are absolute value bars because it doesn't matter whether it's positive or negative. And then you'll divide by the average of those two numbers. You can leave it all in grams and centimeters. You do not have to convert. Since we're just making a comparison, as long as they're in the same units, the comparison will be the same, whether it's in centimeters or meters, kilograms or grams. You're going to do this 7 times. When you're done, I want the average percent difference across the entire lab. Here's the hard part, and this is the part that I'll actually be grading closely. And just between, just so you understand, this is what I will read before I actually look at any of your data, before I look at actually, your calculations. I will drop down and read this discussion. You have to tell me whether you demonstrated conservation of momentum or not. That was the whole point of the lab. Now, I'm going to read the reason why you believe you did or did not demonstrate conservation of momentum. I want it right here after you make this average percent difference calculation. A perfect demonstration of conservation of momentum will show a percent difference of 0. You are not going to get 0. What you have to do is convince me of your reasons why you said yes or no. A lot of you have this idea that I will be upset if you didn't demonstrate it. Like you have to say yes because the lab was about demonstrating conservation of momentum. And nothing could be farther from the truth. What I'm looking for is a no BS answer where you explain how your results do or do not support the purpose of the lab. And I'm not looking for we had errors because we weren't being careful. No, I don't want that. You'll get 0 credit for that. You are not focusing, you're not answering my question. You should consider, because there are specific problems with this lab, things I know you did wrong. I watched you do them wrong. I'm looking for you to consider what you did while doing the lab. Apply rules of physics that we've talked about this year and come up with reasonable support about whether your percentage is small enough to say that you demonstrated or too large and that you think there are specific problems, and outline them. I'm going to read this paragraph critically, and I'm looking for critical answers. It does not have to be long. Being verbose and writing a lot, I don't grade by the inch. I'm looking for you to be able to make a good critique of what you did in the lab. And be honest with what you found. There are specific things that will happen. If you look at your data, I know some things are going to come up. So look for trends. And I'm going to give you at least 2 hints right now. So if you're paying attention, even remotely, these 2 hints should help. First, look at what happens when the masses of the cars get very different. Pay attention to that. Just so you know, when the mass of the car increases, the normal force on that car increases. Do you know any force related to normal force? If so, perhaps you might want to look at an explanation that revolves around that relationship. That shows you using physics to look for possible problems with your data. And that would only explain instances where one car is much more massive than the other. Look for a trend. All right. That's what I'm looking for here. I expect this to take about a half an hour's worth of work. Maybe a little bit longer if you're very careful about your description or if you have trouble making your calculations. Please understand that I did not write times 100 after each of these calculations. I expect you to know that you should convert this to a percentage and know how to. Any questions about this portion of the lab? Yes, sir?
When you said we need 7 examples of percent difference, that means like the 7 different trials we did for the collision, right?
Yeah, so you should have 5 to 7.
Okay.
I'm expecting there to be 7. It didn't take long to take the data. All right, can I go on? Fantastic. All right, explanation for the second part of the lab, or the other part of the lab. I want this drawing redone in this section with some extra work added to it. So give me a moment, because I'm going to draw the same thing you already saw, but a little bit larger here. Close enough. Not great, but it'll have to do. Now, I'm expecting you with a ruler or a nice drawing program to reconstruct this diagram with your numbers, perhaps to a smaller scale. Okay? And you should place all the numbers there that you need. Now, the mass of the 3 balls is unknown unless you went over to the scale and measured it. But since the masses of the balls are equal, the momentum before is just m, the mass of the ball, times this original distance. And since m pervades everything, you can leave the whole thing in terms of the mass of the ball. This will be md1. This is md2. Momentum is a conserved quantity. In this portion of the lab, you did a two-dimensional collision. So I want this to represent the x direction. Was there any momentum in the y direction? Based on this drawing and the assumption that this then would be the y direction, before the collision, is there any momentum in the y direction? No. So you need to do two comparisons here. You need to compare the x momentum before and after the collision and the y momentum before and after the collision. So do you see the calculations I need you to make? You're going to construct a right triangle for each of the momentums that's lined up with the x direction. So calculate the y components of the momentum, and then calculate the x components of the momentum. Oops. Now, yeah. Yeah, that would be a good call, wouldn't it? Let's just back up through time here a little bit, as if I never wrote those out. That didn't happen. Mr. Shelton doesn't make those kinds of mistakes. Thank you. Now, these two should be equal and opposite. It should have equal and opposite momentum in the y direction because there is no momentum in the y direction. These two should add up to equal the original because they represent the x momentum, and this was the original x momentum. That's the comparison I need you to make. It's still a comparison, but it's going to be an obvious comparison. You're going to know whether you showed this or not. And I looked at a lot of your pictures. You can see right on your paper. I mean, just look at this line and this line on your paper, and you know whether you were able to show conservation momentum or not, because they should be equal in size. This angle also should be close to 90 degrees. The closer it is to 90 degrees, the closer this is to an elastic collision. And in most cases, I saw many of them that they're nice and close to 90 degrees. Now, this one's a little more complicated in taking the data and being careful, but there's also 100,000 places where you could have gotten something wrong. There's so many slip-ups. Not dropping the ball the same way every time. Bending the ramp when you were dropping the ball so that the ramp was somewhat skewed to one side or the other because you were leaning on it. The table being leaned on or moved around from trial to trial. The paper sliding around the floor. Not marking the center directly below where the target occurred. Do you understand that if this point shifted, how much your data will be off? Do you see how it affects every single measurement? Little things like that all change the results here. This lab is about care and attention to detail. If you took care and were paying a lot of attention to details, you got good data. And you can tell the groups who did. If you didn't spend time thinking through what you were going to expect, or you blew through taking your data, you can tell right away. Now, this lab actually yields pretty close data if you're careful. You guys who didn't do a nice clear collision and did more of a head-on collision, your data will be harder to interpret. That's why I wanted a nice clear collision, because it's easier to interpret the data. You're still making a comparison, which means I'm going to be looking for a percent difference calculation here and a percent difference calculation here. But I'm also looking for another paragraph. A paragraph that describes to me whether you did or did not show conservation of momentum in 2 dimensions. If you think there's a specific problem in your data, you should be careful to say how it would have affected the outcome. There are a couple of specific errors I'll be looking for. I do want to point something out to help with the question I gave you guys for the evaluation. In this lab, no matter what happened at the collision, the balls took the same time to fall to the ground because they always fell from the same height, the top of the table. Since the top of the table's height never changed, the time it took for the balls to reach the ground should have always been the same because it has nothing to do with how fast they're moving horizontally, which means whether there was a collision or not, the ball took the same amount of time to reach the ground. That's an important detail, and that's part of the reason we can use distance and not velocity. Again, the question you have to answer from the very beginning. The overall thing that we tried to do in this lab was to make time a variable we could eliminate. You need to explain why. All right. I probably put a third or more of the credit in the evaluation of a lab. It's to me where the actual work is being done. But after this comes the conclusion. So do I need to explain this any thoroughly, or do you guys good for me to go on to the conclusion? All right. This lab does not require a very involved conclusion. And I do not need each piece of the lab concluded separately. I need an overall paragraph that concludes the lab by restating your results. Meaning, first paragraph should be a sum up of your evaluations. Did you demonstrate the purpose? Did you show the purpose? Did you find the purpose? That's your first paragraph. Second paragraph. By the way, your first paragraph shouldn't be yes or no. It should be a paragraph, 2-3 sentences. Second paragraph. Carefully describe the errors. I'm not talking about possible errors, I'm talking about your errors. What might you have done wrong? Please try and relate your errors to actual physical things you can see in your data. That's the best way to make me believe you actually thought it through. Last, how could this lab be improved? What could you do to improve this lab? If I was to make students do this again next year, what should I do differently? Now, before